Hello, welcome once again. This is Research and Statistics Guide. And my name is Dr. Felix Ayodele. Now, today I'm going to be sharing with you how to choose statistical tests even for your research. You could be a final year student, you could be a postgraduate student, or you're a young researcher. And you're always thinking what should be the basis of choosing a particular statistical test or the other. Now, in the next few minutes, I'm going to share with you very simple tips that will actually help you in effectively deciding how you should analyze your work. In other words, what are the appropriate statistical tests that you should use in different situations? So I'm just going to go ahead to share my slides, okay? And then we get right into the business. So again, choosing a statistical test can be a daunting challenge to many researchers, both young researchers, final year postgraduate students, and the like. So, but within the next few minutes, I'll be sharing with you what are the basic things you should consider in a very simple way that will help you to decide the appropriate statistical test. Now, number one, the very important thing you should think about is the purpose of that research. The purpose, you have gone to the field, you have collected data, and maybe you have done the sorting of your data, you have done appropriate cleaning of your data. The first question that should come to your mind is that what is the purpose of this analysis? Okay. Of course, generally in statistics, we have the descriptive statistics, we have the inferential statistics. Descriptive statistic is you being able to present your data in form of frequency table, in form of graph, in form of charts. But the other aspect of statistics, which many at times can be a little bit tricky, is the inferential statistics. That is where you begin to draw inference, you analyze even your work, and you make meaningful interpretation, maybe when you are dealing with different groups. So again, the first thing to think of is that what is the purpose? Now, there are two broad purposes generally when you think of the purpose of analyzing your research. Now, the first is comparison, okay? The second is relationship. There are times you are working on different groups and you want to compare which one is better than the other. You have collected information, maybe the performance of students in a particular class. You have the male group, you have the female group, and you want to know, are the males doing better than the female? Okay, so that is a way of comparing. And essentially, when you compare, your goal is to know if there's any difference in their performances generally. Good. Now, another way is to look at the relationship between variables in your research. Now, usually when we do research, more often than not, what we do is that we try to compare variable as researchers, maybe independent variables, dependent variable, as the case may be. You want to know if the performance of students has anything to do with the time spent on reading. So that's a way of comparing variables. So you're looking at the relationship. So two possible ways, once again, is either you are comparing or you are trying to establish if there are relationship among your variable. Now, number one, if you talk about comparing, again, you have the female group, you have the male group, and you want to look at if there's any difference between the two groups. And sometimes if you are doing experimental study, maybe you want to test the impact of a particular drug and all that. That's what you call experimental study, where you make intervention in a particular group and all that. So essentially, you will be comparing treatment group, and of course, you are going to have a control group. So that is still a form of comparison. Now, the other possibility is when you want to group, maybe you put in categories in terms of color, in terms of age, in terms of sex, and all that. So comparison and looking for difference is an important possibility. Now, the second possibility I highlighted is establishing relationship among your variables. Now, the first scenario is what is the equation linking the height and flexibility? You want to know, is there a way I can link, does height affect flexibility? Does feeding affect weight gain and the likes? You have another scenario. Can age predict muscle mass? That could be another thing you are looking for in your analysis. And the third possibility is medication dosage linked to recovery time and the likes? Good. So again, two possibilities. It's either you are comparing or you are trying to establish if there are relationship between your variable. Okay. Now, another important thing you need to also decide or establish that will guide you in the choice of statistical test is the type of data you have collected. What is the type of data? Again, there are two possibilities. We have categorical data. Maybe you have the male category, you have the female categories. Okay, that is categorical data. Maybe you have the graduates and you have those that have not been to school, the literate and the illiterate. Okay, and also another possibility is to have continuous kind of data. This is a kind of quantitative kind of data. Example is your age, your weight, your height. Okay, these are called continuous kind of data. So for the categorical data, for instance, you are looking at political party. Okay, maybe the performance between two political party or what have you, or you want to look at an example like, did memory improve? Did your memory improve? Answer is yes or no. You are looking at a binary response. Okay. And you have the yes category and those that pick the no category, maybe based on a particular treatment. And the last possibility is when you have gene and you want to know which gene was expressed. You are looking at different categories, okay? Where gene was expressed, where gene was not expressed. Okay, so, and the second one, like I mentioned, is the continuous type of data, which is qualitative data. Now you can be looking at your heart rate as an example. You can look at age. These are type of data that are regarded as continuous data or number of bacterial colonies. Now, having established this, the third important thing you need to think of, I told you three things. 1, 2, 3. Number one is the purpose. Number two is the type of data. And number three, now we look at the three families of statistical tests. Usually when you conduct statistical tests, your statistical test, the choice of statistical test you are going to make and settle for will fall in one of these three categories, these three families. Number one, you have the chi-square family, you have the t-test family, you have the correlation family. The chi-square family, when you are dealing with categorical variables, okay? The chi-square family, the t-test family, when you are dealing with continuous variable, the t-test, the Hanover family. These are the possible tests you are going to be using. And of course, you have the correlation family, the correlation, the regression analysis family. So usually, your choice of statistical test will be guided by these three families, okay? Number one, depending on purpose. Number two, depending on what? On the type of data, okay? So let's go back to purpose and type of data. For the purpose, if you are comparing, okay? You are comparing or you are checking, establishing connection or relationship. If you are comparing, definitely, and you have categorical data, you are most likely going to fall within the family of the chi-square family, the chi-square statistical test. You are comparing and you have categorical data, okay? So it's important you understand comparing categorical data, you're going to fall in the chi-square family. And if your goal is to compare, and yes, you still have categorical data, and also you have some portion of the categorical data also indicating continuous form. Maybe you look at the age in two groups, male and female in a class, and you want to check, is there a disparity between the ages of the male in the class and the female in the class? So for the male, which is a category, then you took down their ages, and you have the female group in that same class, you took down their ages. Recall that the gender is a categorical variable. Categorical means it divides the group into two, the male group and the female group. But the age is a continuous variable. It's a continuous type of characteristics within a group or a population. So when you have such two possibilities, you'll be looking at the t-test family, okay? And of course, the ANOVA family. While the third possibility is when you are looking at the relationship. Sometimes you have two variables and you are looking at how do they relate with one another. Not necessarily that one may be responsible for the other, but how do they relate? How does height relate with the weight, the body mass of an individual? We're looking at relationship. It is possible the taller somebody is, the increase the body mass of that individual. That is relationship. Now, in that case, you'll be looking at basic correlation analysis. Okay. But if you are dealing with two variables whereby you want to establish if an additional input on this or an increase in this will have an increase effect on the other one. In that case, you'll be looking at a regression analysis. In other words, you want to know the implication of a unit increase in an independent variable that will result in a dependent variable. Many a times, it is trying to come up with a formula that will tell us that if you make a change in this, then there will be so corresponding change in this. So that is essentially what we do in correlation, in regression analysis. So looking at the table on the screen, you can see the broad overview, okay? Again, when you are comparing group, you have your chi-square test family, and the chi-square test family, you have three types of chi-square tests. You have the tests of homogeneity, you have the tests of independence, and you also have what? You also have the third important test, okay? Which is very important, very basic. What do you call that? Good. Goodness of fit test. Good. So it is the goodness of fit test. We have the test of homogeneity. We have the test of independence. We have the goodness of fit test. Now, I also mentioned the second group, which is the t-test. Okay. And the third possibility, which is the correlation analysis. Now, please understand that all these statistical tests, they are what we call assumptions. In other words, there are conditions that must be fulfilled before you apply the statistical test. And in most cases, it is more of normality. In other words, what is the distribution of your data? Is it normally distributed? Now, when it is normally distributed, usually we say you use parametric tests because it follows natural parameter. But what happens in situation whereby your data set is not normally distributed? There are non-parametric alternative to such situation. And that is where you have the non-parametric alternative, which are indicated here in the screen. So I believe you have gained one or two things from this presentation. Again, my name is Felix Ayodele Oyeleye, and this is Research and Statistical Guide. If you have gained one or two things from this presentation, please do well to share the link, hit the like button, and subscribe to my YouTube channel. And I'll see you in my next video. Thank you for listening.